So covalent bonding is the way that molecules that are made of different non-metals stick together, and it makes individual molecules. So all of the non-metals are over here, and these are the metals. So we're going to be looking at the bonding between the atoms, between the elements, over on this side of the periodic table. So two of the famous examples are methane, CH4, and this is a molecular model of it, and water, H2O, and this is a molecular model of water. So if you draw these out using sticky diagrams like this, you have carbon, which is that carbon. You have 1, 2, 3, 4 hydrogens. 1, 2, 3, 4 hydrogens. You can also get that information from the little 4 there. That little 4 means there were 4 hydrogen atoms. And in water, H2O, there is 1 oxygen, which is red, and there are 2 hydrogens, 1, 2, 1, 2. So covalent bonding is when atoms share electrons to gain a full outer shell. It only happens between non-metals, and a covalent bond is a shared pair of electrons. It's represented by a straight line between atoms in a molecule. So if we look at methane, this molecule here, there's 1 carbon, there's 1, 2, 3, 4 hydrogens, and there are covalent bonds between this carbon, this hydrogen, shown by this bond, this carbon, this hydrogen, shown by this bond, the straight line, this carbon, this hydrogen, shown by this straight line, this carbon, this hydrogen, shown by this straight line. And that straight line there means that carbon has shared 1 electron with the hydrogen, and this hydrogen has shared 1 electron back with the carbon. So we need to look at the number of electrons everything has. We're going to look at carbon, oxygen, and hydrogen, and look at the electron configuration. Carbon has 6 electrons, so it's 2, 4. Oxygen has 8 electrons, so it's 2, 6. And hydrogen just has 1. Now, generally, people will only be asked to draw the outer electrons only. If you've got a big molecule or a big atom, drawing all the inner electrons becomes tedious and it doesn't really give you a lot of information, because covalent bonding only happens with the outer shell electrons. So if we redraw these only showing the outer electrons, carbon's got 4 in its outer shell, oxygen's got 6 in its outer shell, hydrogen has got 1 in its outer shell. So if we take methane, methane's made of C and 4 H's, 2, 3, 4. Carbon's got 4 electrons in its outer shell, hydrogen has got 1. You can imagine that it comes in like this. I'm putting the last one in and then tidying it up. We're in with a molecule that looks like this. So this bit here shows that the electron from carbon, the black X, is shared with the hydrogen because it's in the overlap between this bit, and this blue dot is the electron from hydrogen that's sharing with carbon. And you represent this bit here with that straight line. The reason why it bonds this way is because carbon now has a share of 1, 2, 3, 4, 5, 6, 7, 8 electrons, so it has a full outer shell. Each hydrogen now has a share of 2 electrons, 1, 2, 1, 2, 1, 2, 1, 2. So now hydrogen has a full outer shell. It looks like the molecule. The molecule is 3D, so it's not quite flat like you draw on a page, And remembering that these single lines are single covalent bonds, which show the sharing of a pair of electrons, 1 from carbon, 1 from hydrogen. If you take water, H2O, oxygen's got 6 electrons in its outer shell, hydrogen has 1. So oxygen needs to gain an extra 2 electrons, or have a share in 2 electrons to get a full outer shell. And the way that it does this is it shares this electron with this hydrogen. This hydrogen then shares this electron back with the oxygen. Same for this one. Oxygen now has a full outer shell because it has 1, 2, 3, 4, 5, 6, 7, 8 electrons, and each hydrogen has a full outer shell because it has a share of 1, 2 electrons. This looks like the molecule where the red ball is the oxygen and the white is the hydrogen. And again, these bits here are single covalent bonds because it's a sharing of a pair of electrons. One electron comes from the oxygen, one comes from the hydrogen. If you take carbon dioxide, the well-known greenhouse gas, what you find is that carbon only has 4 electrons, 1, 2, 3, 4. And it needs to get 8 electrons to get a full outer shell. So for that to happen, the carbon has to gain another 4 electrons. And the only way that carbon can gain 4 electrons is to share 4 electrons. So what happens is, it goes a bit like this. So the carbon now has a share of 1, 2, 3, 4, 5, 6, 7, 8 electrons, and each oxygen has a share of 1, 2, 3, 4, 5, 6, 7, 8 electrons. So carbon has shared 1, 2 electrons with the right-hand oxygen, and it's gained back 1, 2 electrons from the right-hand oxygen. Carbon has shared 1, 2 electrons with the left-hand oxygen, and it's gained back 1, 2 electrons from the left-hand oxygen. So if you look at the Molly model, there are 2 sticks, 1, 2, 1, 2, between each carbon and each oxygen. And this is called a double bond. So remember, a single bond is a shared pair of electrons. So if there are 2 shared pairs of electrons, that's a double bond. So each carbon has shared 1, 2, 1, 2. And if we look at the carbon bonded to the right-hand oxygen, there is 1 pair of electrons there and another pair of electrons there. So there are 2 pairs, so it's a double bond. And the double bond is represented by what looks like an equal sign. It's actually just 2 single bonds, 1, 2, one on top of the other.